There is some power supply problem with VC's office. So
Yes.
should we start?
Yeah, please.
Okay. Good afternoon, ladies and gentlemen. I am A. Gaikwad, Joint Registrar at Delhi campus, Nfsu. I very earnestly welcome all the participants, especially team from CDAC, members of CDAC team from Bangalore, Dr. Sudarshan, and Mr. Bindu Madhwa. And I also request Mr. Santosh from Meti. We've been talking to Harish since a long time. Probably this is the first time that we are all together on this platform. On behalf of Vice Chancellor Padma Shri Dr. J.M. Vyas and our campus director at Delhi campus, Dr. Tunare, once again I welcome all of you for today's workshop. It's a small workshop, extremely useful not only for the individuals who are participating here, but it is extremely important for India because we have a very large population utilizing the internet domains, but we do not have the say in policy making when it comes to at international forum. Okay, so what we have launched or we want to do through the medium of workshops and seminars is to spread awareness on internet governance, especially the domain name. With this small workshop, we want to empower our participants so that they get a little edge in their career with the knowledge of DNS. Also, the students of forensic would have special skills once they get into this domain name servers from the point of view of carrying out some kind of forensics when it is required, when there is some compromise on DNS or there is some activities which are happening on DNS. This will also empower all the participants, whether on the student body or other professionals. It will give you more clarity on the internet security, which is we are not very sure. Through the internet, all our critical infrastructure is getting vulnerable. We do not have answers to all the vulnerabilities, but before we get the answers, it is very important for all of us in India to understand the internet. Once we understand the complete working of internet, how the domains are controlled by certain organizations across the globe, how much say does India as a country have in policy making towards this, all this thing will follow in subsequent workshops and all. But today we want to begin with imparting certain knowledge to the participants, like I said, which will enable them or which will give them some kind of an edge in their career compared to others, and so on. At the national level, we would be able to strengthen our internet security, which is so important, especially with what is happening between Russia and Ukraine. Kind of problems that are how we may be isolated. I think we missed the last point. This internet governance and DNS security is a very essential part which we need to understand in our country, especially in the backdrop of the conflict between Russia. We're slowly getting more insight into what is going to happen to our critical infrastructure, what is going to happen to our war fighting capability, which is riding quite a bit on the internet architecture. With this, probably I'll open the workshop for today. I would thank in advance the team of CDAC and the team members of Nfsu team at Delhi for organizing this workshop of Nfsu across all the 4 campuses in India. May I request Dr. Junnare sir, Campus Director, Delhi Campus, to say a few words. I'll just get him on line. Huh?
Hello, sir.
Sir, may I request you to say a few words on this workshop? Just a couple of hours workshop, but extremely important from the student's point of view.
Hello.
We can hear you, sir.
Sir,
we can hear you.
So I'm actually suggesting that can we have little introduction of all the dignitaries and our resource persons, and then we'll start for our session. So first of all, on behalf of National Forensic Sciences University and our Honorable Vice Chancellor Padma Shri Dr. J.M. Vyas sir, I welcome all the dignitaries who are actually the part of today's special workshop on DNS ecosystem and security. So on behalf of my university, I welcome Honorable Dr. Santosh Khansare Air Commodore Thakur Sahib, our professors from actually CDEC, senior officers and dignitaries from CDEC, my faculty members, and of course the professors and other participants who are participating in this special workshop on DNS ecosystem and security. As Air Commodore Gaikwad ji told that actually this is very important actually subject which we have chosen for the today's workshop, and the meaning of workshop is actually the having some practice of any work, or this is a practical demonstration or working in the particular subject. So I request all the participants to take part in this special workshop and to actually get all queries resolved, or you can actually get your answers which actually you want to take from these special resource persons. So I will be happy that if everybody participates and actually discuss these very important issues of DNS security, particularly DNS ecosystem and security. So, as you know that National Forensic Sciences University is the only university in India as well as world which is actually catering the needs of education, research and training in forensic science and allied branches. So, which includes the cyber security, digital forensics, AI and all actually IT related services. So, this university is taking lead in research in very important and innovative areas, which includes actually these DNS services and even AI and robotics and even drone forensics and so on. Cyber security and digital forensic is a main core hardcore area of our interest, and we conduct more than 70 programs in our university, and mostly the programs are postgraduate program. Around 65 programs are postgraduate programs and 5 programs are undergraduate. So presently the university is running its academic and research activities through 5 campuses at present which are in operations. That is one of very important and prominent campuses at Delhi. So Delhi campus actually known for its innovative ideas and actually new innovative initiatives for conducting different types of seminars, workshop and research activities. So I welcome all of you to take part in this special workshop and actually get more insights, and also to suggest some actually very important policy initiatives which can be taken by Nfsu in consultation with CDEC. So as rightly Air Commodore Gaikwad sir told that actually there should be actually say in all policy making in not only in India but in the world, because India is global leader in several aspects including IT and cyber security and actually all actually new initiatives. So I request the honorable resource persons to deliberate different issues on these areas and actually make a concrete solution or give a concrete solution that how India can be a global leader in all types of policy matters in this IT as well as all cyber related and DNS entire DNS ecosystem, so that actually you can say that India is a global leader in all aspects. So actually during this workshop, I suggest all these actually members who are actually taking part in this special workshop, so they should also suggest some actually proactive measures or some good initiatives which can be taken by government of India as well as Nfsu, and how Nfsu can be the part of different policy initiatives as well as different activities promoted by the government or for the government, or actually I will say that actually on behalf of government. So the Nfsu is always ready to support, to take part and to help other organizations as well as the be a very active partner of government of India. So I thanks all the members who are actually present today, all the participants as well as all the resource persons and actually the members of our university, including a coordinator of this special workshop. So thank you once again for actually inviting me for this special workshop. So though actually I'm traveling somewhere, so I could not take part in physical mode. But next time I'm assuring you that I will be there to take part and actually try to learn a lot of things from all the learned these resource persons as well as audience. Thank you very much, sir. Thank you.
So thanks a lot, Dr.
Thank you.
Now, before we
So
proceed and before we start the workshop, just a question for all the participants. Attention to the each and every lecture. At the end of the session, the workshop, we will conduct a very small exam which will be online. Passing this exam is essential and necessary for you to get the certificate. So just a point of caution that kindly pay attention fully, and not only pay attention for this particular workshop, but start thinking as to what should be the next step in your career in the domain system management and governance. With this, may I request Mr. Santosh to kindly take on and commence the workshop, sir.
Yeah, thank you, Mr. Gaikwad, Air Commodore retired Gaikwad, for having me as well as NFSU for organizing this webinar on DNS ecosystem and security. So I would also thank the director, Dr. S.O. Junari, for inviting me for this webinar. And also CDAC officials like Sudarshan ji, who is the executive director of CDAC, Bindu Madhava, the senior director, CDAC Bengaluru, Dr. Balaji, and Gopinath for conducting this webinar under a project which was funded and supported by both Ministry of Electronics and IT as well as National Internet Exchange of India. Now, a lot of things we have been mentioning about DNS ecosystem, security. Now here the screen is also written as public DNS server. Now, going to that, I would ask, what is internet governance? So, what is internet governance? Can anyone message? They can, if possible, they can message in the chat box. Well, internet governance is basically the policy as well as the technical matters related to internet domain names, then internet protocols, which is numbers, and the third aspect is protocols, which are the standards. So these are the basic three major things by which internet functions. So there is a governance structure for that as well. Now, if you see that internet was invented by the United States of Academy, well, this was invented in the DARPA lab, as many of the people might be knowing it. Now, the invention was such that the utility is being used by public at large. 4.5 billion population globally are using this internet. Can you imagine? It started with a lab and now it has moved out and everybody are using it. Now the problem comes to maybe your mind also. Who controls the internet? Now the thing is that maybe 10 years back, if somebody asked me from where internet comes, I will say it is from the internet service provider. Beyond that, what are the structures? Right? So that is the webinar all about. So I'm just giving an insight. What is this webinar all about? So coming back to the internet governance. So basically, we in Ministry of Electronics and IT, we are responsible for the policy and technology matters related to the names, which I have mentioned as internet domain names, like as you have seen .com, .in, .org. Now, the concept note, if you people have read, it has been mentioned that there are many number of domains. So can the domains be classified? Right? So there is a top level domain, there is a second level domain, there is a third level domain. So that is how the naming function comes, internet naming function comes. Now, second factor, most of you might be knowing it. Even in the screen, you can see that the slide, it is written at IPv4, IPv6. So these are basically the internet protocols, or basically the numbers, right? So usually the computer identifies only the numbers, not the domain names, right? Domain names are basically for us to remember easily. Now, from where this has come? Who has made it? Which is the organization who has made this? Right? Are we participating in this? Okay. So these are the questions you might be asking. So there are many global bodies. So on internet names, if you have seen, in the screen itself, you can see there is a on the right side, it is written as ICANN. What is this ICANN? What does it does? Now coming to the IPv4, who provides these numbers? From where you can get these numbers? So that will be deliberated in the coming session. I'm not going deep into it. So our role is to give awareness on internet governance. We use internet, but do Indians have a say in this? Can I in policy making of the domain names? Can I have a say in the policy making of the numbers? Now, how many IP addresses India gets? How many IP addresses another country gets? Since we are most populated countries, can we get more IP addresses? Right? So these are the questions. So these are the questions to be asked. So as I had mentioned, ICANN, IETF, that is Internet Engineering Task Force, as well as Internet Governance Forum, then Internet Society. These are the various organizations which are responsible for the internet by how it is functioning. Now, you may be amazed to know that there are many servers across the globe by in which we are able to communicate. This is basically a technology above the internet. Now, when you type a URL, you are getting connected to a website, say nfsu.ac.in. Now, how it connects? What is DNS basically? Yes. So, domain name system is the heart of the internet, how it functions. Who are responsible for DNS? So in India, again, in the slide, you can see NIXI, which is National Internet Exchange of India. Now, National Internet Exchange was made for basically Internet exchange. Why we require Internet exchange? So I'm just posting few questions, not giving answers, because you can think, right? And the second operation of NIXI is .in, right? If you have seen nfsu.ac.in, NIXI provides, NIXI provides .in domain. Now, what is a .in domain comparing to that .com? What is the difference? Okay, let me say to you that .in is a country code top level domain, whereas the .com is the generic top level domain. So there are variations in the domain names also. So I'm not going much into detail. I'm just mentioning what our ministry doing in the matters related to internet governance. So earlier, mostly this internet governance in India was a multilateral. We took a multilateral position. That means government should have the control. But during 2015, the present government took a decision that the position has to be multi-stakeholder. Now, what do you mean by multi-stakeholder? Multi-stakeholder is basically a concept in which all, like civil society, NFSU like academia, research organization, business entity, and the government comes together and they work for the internet, what we see. Now, now if you ask me what India wants, I mean, what is the policy of internet? So in simple line, I can mention that the internet which we foresee is open, safe and trusted, and accountable internet. That is what we foresee. We want that kind of internet. Open means it has to be open to all. Now, another question will come. We have 130 crore, now 1.3 crore billion population. How many of them are using internet? So you may have come to some records of CLI, that is the Telecom Regulatory Authority of India, stating that around 83 crore are using internet. Why the remaining people are not using internet? What is the barrier? So for that concept, excuse me. So sorry for that. So for that, a concept called multilingual internet has been thought by the government. So multilingual internet is that any person can surf internet using his or her own language. So URL could be in Hindi or URL could be in any of the language. Email ID could be any of the language, right? Now the systems are in place, but gradually we have to move into that. So this webinar will be mostly explaining about the domain name system, and domain name system, as I had mentioned, are the integral part of the internet by which we use. So how to protect this domain name system? What are the components related to that? So what are the latest standards? Now DNS we know, but how DNS is communicated? What are the different transport protocols? So that will be explained in the coming for the webinar. So I request each participant over here to kindly concentrate on the webinar being made. There are many changes made in internet on a daily basis. Technology on internet is changing like anything. New technology are coming. Are we adapting that? how is my privacy maintained in the internet? Okay. Now for law enforcement agency, whether are they able to get all the information timely? So these are a few answers which are part of the internet governance issues. So once again, thanks for inviting me for this webinar, and I wish all the best for this webinar. Thank you for coming.
Thanks a lot, sir. This is Harish Chaudhary for the record, and thanks a lot for the insight to all the participants. And further, we will, actually working here at NFSU to support internet governance, technology, as well as the policy basis. Now I would invite officials from CDEC so that they may actually explain about the DNS security, as well as importance of domain name system and the initiative of Government of India in terms of center of excellence in DNS security. So over to CDEC, Mr. Gopinath.
Yes, thank you, Mr. Harish Chaudhary. Yes, sir. Bale, sir.
Yeah. Thank you. Thank you to NFSC members as well as Santosh sir for setting the outline about the internet governance and background for DNS. So now I request our Executive Director, Dr. Sudarshan, to address the gathering, sir.
Good afternoon, everyone. Am I audible?
Yes, sir, you are audible, sir.
Good afternoon, everyone. Oh, very good. Thank you so much. First of all, namaskar. Thank you, NFSU, for organizing a seminar and webinar. It's extremely in digital world, which is dependent completely on internet related technologies. Even on intranet, we end up using internet technologies. So this is a very, very important topic, and the NFSU being the forensic science university, they should be, they are already aware, but they should constantly update as much as we do at CDAC and the mighty team and everyone involved. On a daily basis, changes are happening, and we should be 2 steps ahead of the adversary where it is possible. We do know that there are areas where we cannot be forward. We have to only catch up because we cannot act on intent of the. We can only act on actions. So ours have to follow up what units that are relevant to all the parties. I'm sure the entire NFSU team, from the Vice Chancellor to the team will like that. And our Santosh ji from AT has in fact kind of us, and but he also brought out exceptionally in a very lucid manner why is it significant, and also why is it, we are stuck at 83 crore or whatever that number, which is not even 50% of the actual number we are looking at, because today India is looking at an inclusive society where everyone is having equal access and equal diversity on the entire ecosystem on any technologies, and the least being the internet. So in that context, our team, Mr. Bandivadava, Dr. Balaji, Gopinath, the whole team is here, who will take us through. From my side, maybe I'll just highlight just a couple of points. First, there are places where we are tricked as a user of internet to go to a wrong location, and then there are a lot of things that can go wrong in an internet, and many of us are aware of. But there are certain things where we believe on certain trusted intermediary, and then we proceed from there. But how can the intermediary be fully trusted? Normally, it all depends on the protocol and configuration settings and so on. And DNS is one thing which actually is saying it's a, it has to resolve your domain name and tell this is what it means. And the SOP is based on, if I come and say, this is what I mean by something, and me being the source, you have to trust me. But my trust itself, trust on the entity which is providing the input, it is assumed. So for DNS, the root of trust is always based on, assume that it is right, because majority is right. So almost an equivalent in firewall is, typically we say public websites permit all except few, whatever, where we know they are culprits. But on day 0, we assume everyone is white. There is no blacklisting. Whereas in a defense kind of scenario, we can go with the deny all except. So we get a whitelist. In the other case, we get a blacklist. So in case of blacklist, initially everyone is white till you find issues and improve upon it. So DNS is more or less on that philosophy. So there are few things that we can do, which I am sure the webinar will cover. But there are few things we need to always assume. But one good thing is DNS servers, we can cross-check, certain best practices can be followed so that only the genuine ones make it to it. And the rest maybe cross-check, certain techniques are possible. So from that perspective, this webinar is extremely critical. And it is one piece of the big jigsaw puzzle, which very few people understand the details. So I think I would like to stop here at this point, because making general statements will not cut ice with a technical audience like you. And the team has more than enough information which cannot be covered in the allotted time slot of 2 to 2.5 hours. And so I will let them go into whatever detail they can go. And key point is MeitY representing our government, trying their best to keep the internet governance as smooth and as inclusive, accessible as possible. And they are collaborating with multiple international agencies. And Mr. Santosh is leading a number of such initiatives and supporting us. And our CDAC project is also very much supported by them. Thank you, sir. And Nfsu team, I think, as I said, there are places in cybersecurity where we only have to catch up. But there are some areas where we can be 2 steps ahead. And those 2 steps ahead, in case of DNS, may be covered today. And that much, we are better prepared to serve our country and the society at large. So with that, thanks for the wonderful event being organized, and wish you everyone a good, exciting journey in the security domain, particularly in DNS. Thank you all. Thanks.
Thank you, sir. Thank you for covering all the perspectives of the DNS ecosystem. Thank you very much, sir. Our sessions also will ensure that it covers in depth all the contents. Now I request our Senior Director, Mr. B.S. Bindu Madhava, to address the gathering. Over to you, sir.
Good evening all, and I would like to welcome all the participants to this particular DNS ecosystem and security workshop or a webinar which is being jointly organized by NSFU and CDAC under the aegis of MeitY. I think a lot of things have been covered by the previous speakers, but somehow assuming that DNS is all working fine, and the security aspect also has to be looked into. Assuming that the model which is followed, which is a transition from multilateral to multi-stakeholder. So to that extent, even the privacy issue becomes very important. That's what Santosh ji was mentioning. So the security and privacy becomes an important aspect in this particular domain. Assuming that a part of the cybersecurity where mostly the availability of the system is looked at, and then subsequently that portion is very critically looked. Now, I think there was a mention that DNS becomes a big major component of the internet, and that's how the internet-based applications becomes uses this critical information infrastructure very critically. So that's how it becomes DNS also is a critical component, and it can have major disruption and major impact can be created. I would like to sort of put some pointers because DNS is a critical component. So the threats which are possible on this particular space, assuming that complete DNS ecosystem is covered, and what are the possible classes of threats which are possible on this particular component, which is very critical. So the first and foremost class of threat which is being discussed is the denial of service. So that becomes very important. The second is the data corruption. That also is an important thing. Again, it all depends on the resolvers which is there, from a normal understandable names to the machine addresses. So that's where if there is a corruption, how does it get resolved and other things. And again, the information exposure. So these are the some of the defined class of threats on the DNS. Now, actually, the DNS itself might create some problem for the operations, and there can be some attacks on the DNS. Also, the DNS itself can have some sort of threats created. So what happens is, if we are trying to sort of categorize that, the threats to the DNS, which is based on the denial of services component, that's where the physical infrastructure, the network infrastructure, and the DNS infrastructure, and the administrative infrastructure, and technical infrastructure comes into the picture. So these are all some of the things which some of them falls under policies, some of them falls under the technological implementation. When you come to the network infrastructure side, again there's something called as the core network infrastructure, where threats can be there, and the server edge infrastructure, that is another area where there's a lot of research happening, and the client edge infrastructure. So with denial of service and having so many infrastructures in place, and the network infrastructure becomes important, and there are certain things which has to be looked in this particular thing. Now, when it comes again the threats of the to the DNS, and when it goes to the class of threat which is data corruption, so there also there is a lot of things which has to be looked at. The authoritative impersonation, authoritative server corruption, cache corruption, again application to cache corruption. So this is one very important thing, and then can be a system corruption also. I think already some mention was made on the protocol. So if there is a protocol corruption, that also is one of the things which is possible. So again, when you come to the threats to the DNS under that category itself, like I told, the third class of threat which is to be looked at is the information exposure. which there is a lot of activities happening, and the RFCs are also there, which is running. So something called as domain front running, snooping, and zone walking. So these are some of the three things which comes directly under the information exposure and under the threats to DNS. So this is one the thing. The other major thing, threat from DNS itself. What is that threat from DNS itself? Which can happen is when there is a query, small query coming, there can be large replies coming to that query. So that is, there's something called as DNS Simplification Attacks, which is possible. And this is the area where which has to be looked into the authoritative amplification as well as the resolver amplification. So this is from the DNS, the threat from the DNS itself. And one more thing which is from the threat from the DNS is something called as false flags. This is nothing but empty number of replies and queries which gets jumbled up, so that there is no proper this one replies going to the client side. The other major thing which there is an RFC which people are working on is the DNS as a coverted channel. Some sort of a backdoor which is possible. This is another area from DNS, the threat from the DNS, which becomes important. So I thought that these are some of the pointers which common DNS threats which are classified and used, and the RFCs are available. People can sort of pick up any of these things, which is very important. Assuming that this particular program, they learn firstly what the DNS ecosystem is, and then subsequently what are the possible threats and different classification of threats. So I thought with this particular thing, this is the major gamut of things which are happening. It is not only the security aspect, but the resiliency of the internet also is being discussed. So with this particular thing, I wish all the participants try to sort of participate actively and try to see what are the things which can be got today, and then subsequently in future you can contact us. We can see that how we can jointly sort of solve the major problems which is in the offing for the nation. So thank you and all the best for the participants. Thank you.
Thank you, sir. Not only the outsider threats, but the insider threats also we will try to discuss in today's session, sir. And now, without further much ado, I will request request Mr. Gopinath to start the session first.
Thank you, sir. Yeah, good afternoon, everyone. So I'm Gopinath, and I'll be starting the session today. And let me just stop sharing the screen, and I'll just change the slide. Yes, hope the screen sharing is visible. Right. Okay. So today we'll be focusing on this agenda. This will be the agenda for today's session. We'll try to understand what is a domain name exactly. What do we mean by calling a name, calling entity as a domain name? And we'll have an introduction to the DNS. We'll understand what exactly is DNS, and then we'll understand the DNS ecosystem as a whole. We'll try to understand that. We'll understand the DNS hierarchy, which is the technical architecture of the DNS system. So we'll understand the DNS hierarchy, and then we'll look at bind, components of bind. And bind is the open source software, one of the popular open source softwares using which a DNS server can be configured and set up. So that is bind. And we'll come across a tool, a popular tool, which is called as dig. and it is domain information grapper. And this dig is conventionally used for checking the operations of a response of a DNS server, response provided by a DNS server, whether it's working or not. And then we'll have a hands-on. We'll go through a demo of setting up Recursive Resolver, and then we'll have how to set up an authoritative server. So this completes the agenda for the session today. And further after this, there'll be a session on email security. So the first part is on DNS and its configuration. Okay, what is a domain name? What is a domain name? So here you have a URL listed, and you can see the URL is coidnssecurity.in and /about/details.html. Actually, there is no URL of this kind actually existing. The domain name exists. Okay, this coidnssecurity.in is the domain name. So I have just taken this for an example, and Dns security is the domain name, and this is the further path. Okay, this is the further path to an internet resource, and the name of that internet resource is details.html, right? So, and this is accessible through a protocol, which is the HTTPS protocol, meaning the secure HTTP protocol, right? So this part on the right is the protocol, and the domain name which we are looking for is coidnssecurity.in. This in conventional terms is also called as the host name, right? So host name and domain name are interchangeably used several times. So coidnssecurity.in is the domain name. When we say domain name, it means that it is the name of a machine on which, or a server on which, a certain internet resources are hosted. Okay, and that is the name of that machine in the internet. So across the world, across the globe, anywhere we give coidnssecurity.in, it is going to access only one machine, and that is this machine, right? So coidnssecurity.in, where it is hosted. So the further path is the file path. So you navigate through this path to fetch the details.html. This is the resource file, right? So basically, domain name is the primary one, which is used to identify a machine hosting an internet resource, right? So that is what is a domain name. Now, introduction to DNS. What exactly is DNS? DNS is a very important component of internet. In other words, we can also say that it is a very critical component of internet. It is difficult for internet to exist without DNS. Meaning, you can come to the second point. The second point says it all. It translates domain name to IP address and vice versa, right? Vice versa. In certain cases, we require the vice versa also, where IP address can be translated to domain name for technical purposes. For research purposes, we may need that requirement. But for a conventional user, normal user, a domain name has to be translated into an IP address, right? So it is actually like I know that there exists a website by name coidnssecurity.in because it is hosted by us, right? But if you ask me the IP address of coidnssecurity.in, it is difficult for me to recollect, right? So you know that the internet works with IP addresses, and it is difficult for an end user or an internet user to remember a given IP address, right? He cannot be remembering all the IP addresses of all the websites which are present in the internet, right? So in order to give the convenience of remembering a given website, DNS provides a domain name to an IP address, right? So DNS is the body which provides a domain name to the IP address. So a person is expected to only remember the domain name, and DNS helps you link that domain name to the IP address and help accessing the internet resource. That is what is DNS. So DNS translates domain name to IP address, right? So that is the requirement of a DNS. It is a distributed system. You know that internet itself is a world wide web, right? It's a world wide web, and it is a global thing, and it has to be present across the globe to ensure accessibility and availability of internet resources, right? So in that way, DNS is a distributed system. A DNS is actually monitored and maintained by two bodies primarily across the globe. One is called as the ICANN, the other is called as the IANA. Okay, ICANN is nothing but the Internet Corporation for Assigned Names and Numbers. The ICANN is the body which regulates the internet, which places policies and guidelines for usage of internets and administrative privileges on the DNS ecosystem. It's completely maintained by the ICANN. And IANA is the Internet Assigned Numbers Authority, right? If I want to host a website, right, I first need a machine for that, and I host my resources in that machine. I connect that machine to the internet, right? When I connect that machine to the internet, it gets an IP address, right? So that IP address has to be now linked to a domain name, and that is what is your DNS, right? So IANA is the one which provides that IP address, right? IANA is the one which generates the list of IP addresses, and IANA distributes those IP addresses across the globe to several agencies and countries, right? For example, every country has a national internet registry, NIR they call it. They have a national internet registry, and India has a national internet registry, and IANA has provided a set of IP addresses to national internet registry. And the Indian Internet National Internet Registry will be the responsible agency for distribution of IP addresses in the Indian territory, right? So it will regulate the usage of distribution of IP addresses for usage in Indian soil, right? So IANA is the global authority, and it distributes addresses to national internet registries of each of those countries, and those national internet registries take care of distribution of the IP addresses in respective countries, right? So the overall, the complete DNS is actually monitored and taken care of by the ICANN and the IANA, right? Both IANA comes under the ICANN administratively for usage of IP addresses. So both these combined form the naming and addressing authorities of the globe, right? So there are totally 13 root servers across the globe, right? So I'll just take you to a different page a little later, but as of now, you may just register that there are 13 root servers across the globe, and it starts from they call it as A root server, and it goes till M root server, ABCD till M, right? So there are totally 13 root servers. And there are several instances of each of those. For example, a root server will be present across the globe at several instances of that a root server will be present at several locations. So there will be one primary a root server, and others will be instances of that, a mirror of that a root server present across the globe. And that is again it is a distributed system to ensure availability and accessibility of internet, right? So basically there are 13 root servers across the globe, starting from, they call it as A root server, B root server, goes on till M root server, right? So, okay. Now, this is the DNS ecosystem. Let's understand briefly what exactly is this. Okay, so this is the DNS ecosystem, and so let's say that I'm Gopinath and I want to register a domain name. Gopinath.in is the domain name which I want to have and host my personal page at gopinath.in. So I'm the registrant, Okay, right. I am the registrant, and I will post. I'll be requesting registrars, asking them that, see, I have a machine and I have hosted my internet resources on that machine, and this is the IP of that machine. Please provide me with the domain name gopinath.in for that machine, right? So I'm a registrant and I request the registrars to register my domain name, right? So the registrants can approach the registrars for registering domain name. The registrars will check with the registry. This is the registry. This is the registry, and registrars will check with the registry for availability of the requested domain name. If gopinath.in is available, then the registrar would register the IP address against gopinath.in in the registry and provide me the domain name gopinath.in, right? And these registries are accessed by the name servers. So this part in the bottom, this bottom rectangle represents a registration process, a domain registration process in brief, right? So this is the domain registration process, and the rectangle in the top represents the access part. So a user wanting to access gopinath.in will enter gopinath.in in his machine, and the request will come to the closest recursive resolvers. Recursive resolvers will ask the name servers for gopinath.in and take the response and give it to the users. I mean, the end terminal which requested for gopinath.in, right? So the bottom part is the registration, domain registration part, and the top part is the name resolution, domain name resolution part, right? So these are the two parts, and in brief, this is the DNS ecosystem, complete DNS ecosystem. So you have several. If you ask me for a registrar example, you have many popular registrars across the globe, and anyone can be approached to register with the for a given domain name, right? And yeah, of course, so certain registrars have access to certain TLD registries for adding domain names, right? Those differences are there, right? So the idea to be taken here is that this is the registration part, domain registration part, where a user or registrant wants to register a domain name by approaching the registrars. The registrars have the privilege of accessing the registries and make entries. And this is the domain name resolution while accessing a domain name through internet. So the users ask for a domain name. It reaches the closest recursive resolvers, and the recursive resolvers ask the name servers. Name servers read it from the registry and provide the response to the users the same way in the reverse, right? So this is the DNS ecosystem. DNS ecosystem contractual agreements. What are the agreements which happen between the different entities of a DNS ecosystem, right? We have seen registrant, registrar, registry operators, and ICANN is the governing body. We have seen registry operators, registrar, and registrant in the previous slide. Resellers are mediators between registrars and registrants if required. There are certain resellers also, retailers. And ICANN is the governing body, which takes care of the holistic agreement scenario between entities in the DNS ecosystem, right? So ICANN authorizes registrars by registrar accreditation agreement, and ICANN coordinates with the registry operators to a registry agreement, right? So both registrar and the registry operators are bound by the rules and guidelines of ICANN, right? So registrars and registries have to take care of that. And ICANN, of course, manages the root instances. As I said earlier, there are 13 root instances across root servers across the globe, and these 13 root servers are managed by ICANN, right? ICANN regulates registrars and ICANN regulates registry operators, right? Now coming to the right side part, you have a registrant. A registrant for registering a domain name can either approach the reseller or can approach the registrar. So registrant ends up having an agreement with the registrar, which is a registrant agreement for registering a domain name. Or if the registrant approaches a reseller, then registrant has a registrant agreement with resellers, and resellers and registrars have a reseller agreement between them, right? Similarly, registrars for making registry entries with registry operators, they have a registry and registrar agreement on this, right? So this part is the backend database management part. The registrars, registry operators, and ICANN are the backend database management partners. And whereas this is the front office structure, which is the registrant, resellers, and the registrar. Right. So this is the DNS ecosystem contractual agreements scenario. Right. Okay. So hope we can proceed further. Okay. Yeah. Coming to the primary part, which is the DNS query resolution. How does a query resolve in a DNS ecosystem? How does a domain name get resolved in a DNS ecosystem, right? So if you carefully see here, we have three parts here. One is the user who is accessing the internet. Second, we call it as the recursive resolver or the caching server in the center. And this on the right hand side is the these checked boxes, checked server boxes, three of them. This is the DNS hierarchy. These are the name servers, and these are present in the DNS hierarchy. And this is the machine which actually hosts the internet resource, which is, for example, we have taken CODNS security.in as the example here, right? Okay, so let's say that a user requests for CODNS security.in. Every client, every terminal device, every edge device, let it be mobile or let it be a desktop or let it be a laptop, any personal electronic device connected to internet has a local cache residing within itself, in its operating system or in the browser, right? So it has a local cache resolving present within itself. So when a user requests for a given domain name, for example, CODNS security.in, the operating system first checks for presence of the IP address within itself, within its cache, right? Within its buffer, within its local storage. So if an edge device is a continuous or regular visitor of CODNS security.in, then the domain name to the IP address mapping will be present in the machine itself, right? Unless until if the cache is not cleared. So will be present in the machine itself, and resolution of domain name to the IP address will happen at the edge device itself, at the end device itself, and meaning the browser has got the IP address now, and it can directly hit the machine and fetch the resource, internet resource, CODNS security.in, right? Whereas if the user is not a regular visitor to that given domain name or the website, then the cache user's machine will not have the value of domain name to IP mapping in the cache, and the request from the machine is forwarded to the closest recursive resolver. It is forwarded to the closest recursive resolver, which is also called as a caching server, caching DNS server. So will be forwarded to the closest recursive resolver. Recursive resolver also has a local cache. As the name says, it's also a caching server. So recursive resolver also has a cache. So it checks for the domain name to IP address within itself, within the cache, within its own cache. If it is present, it returns from there. Okay, response if found in our recursive resolver cache. Right, if it is found in the cache, then in step 3 it returns to the user and the machine can directly hit the Dns security.in. Right, so this is the second minimal step which is possible. Let's assume that the recursive resolver does not have the entry in the cache. Then the recursive resolver, as the name says, it's a recursive resolver, and it will recursively call the DNS hierarchy name servers, asking them for the domain name, for the IP address of COE-DNS security.in domain name. Right. So in step 4, request root information. Right. So it requests for COE-DNS security.in from the root servers. As we know, there are 13 root servers, and there are several other instances of these 13 root servers across the globe. And this in step 4, the recursive resolver asks the IP address of COE-DNS security.in from the root server. Root server will have the entry for the TLD, which is COE-DNS security.in. That in is the TLD, top level domain they call it. The in is the TLD, and the root server will return the location of .in name server. Okay, so the root server, which is the dot instance, will return the location of the in name server, right? .in name server, and then the recursive resolver approaches the .in name server. It approaches the .in name server, asking for COE-DNS security.in, and this .in name server server's next level is COE-DNS security.in. So it will return the name server location of COE-DNS security.in. So the recursive resolver now in the 7th step will approach the COE-DNS security.in's name server. So this name server will for sure have the IP address of COE-DNS security.in, and in the step 8 it will return the IP address to the recursive resolver. This recursive resolver will save the IP address of COE-DNS security.in in its own cache and forward it to the user, forward it to the edge device, end device, right? And the end device can directly hit the host machine of COE-DNS security.in and retrieve the resource, internet resource hosted at COE-DNS security.in, right? So this is the complete flow. So there are 2 places where cache work here. One is in the edge device itself, in its local cache. If it is a frequent user of a given domain name, then it will resolve in its local cache itself. If it is not able to resolve at its local cache, it approaches the closest recursive resolver. And today we are going to have a look at how do we host a recursive resolver, right? So it'll approach the closest recursive resolver, and this closest recursive resolver also has a local cache, and it will check its local cache. If it is not present, it traverses the DNS hierarchy starting from the root, TLD, and STLD. Okay, so the root will be providing the location of .in name server, and the .in name server will be providing the location of name server for COE-DNS security.in. And this COE-DNS security.in will return the IP address of the COE-DNS security.in host machine. And finally, the edge device will hit the COE-DNS security.in host machine, right? So that is the query resolution process. Okay, hope I have answered the question on what is a recursive resolver. A recursive resolver is also a caching server, and a caching server stores the mapping of a domain name and IP address, and if it does not have the mapping in its own cache, then it traverses through the DNS hierarchy to resolve DNS hierarchy by approaching the name servers of the DNS hierarchy to resolve the domain name and give the response back to the edge device. Right. So that is what is a recursive resolver. Okay, and this is the DNS query resolution process. Okay, coming to the DNS hierarchy, and we'll just briefly go through this, and this is nothing but okay, fine. I'll just touch it. So this DNS hierarchy, nothing but you can see here on the right hand side, the hierarchy is listed here. It is the root, which is the dot, and okay, important point which I think missed out in the earlier part of my session is that when I give a name coidnssecurity.in in the edge device, I give the name coidnssecurity.in. That coidnssecurity.in has a hidden dot appended to its end after the domain name. So it is actually coidnssecurity.in dot. So the last dot is what is representing the root server, right? So when the coidnssecurity.in dot reaches the recursive resolver, it pulls out the last dot, which is the root instance, and it root server, and it contacts that root server to provide the name server of .in, right? So there is always a hidden dot at the end of a domain name of any of those domain names. So that is what is this dot. The root server is represented by a dot, and the level below that is a top level domain, and here we have this root server, and after that root server we have TLD. This is the top level domain name server for .in. This is the top level domain name server for .in. Similarly, we have the next level, which is the second level domains, and we may have third level domains also. So there can be third level domain, and there is another level also possible, but beyond that it is not allowed. It's not allowed in the DNS hierarchy. So there are top level domains, and these top level domains comprise of a set of domains like edu, org, com. These are called generic top level domains. These are generally used. Org, com, these are generally available, generally used top level domains, and these are called generic top level domains. Similarly, for each of those categories, each of the defined categories, there are separate top level domains, and there is something called as country top level domain, country top level domain, CCTLD, which is one of them is .in for our nation, which is .in. Similarly, we have .us for US, .ru for Russia, and so on. Right? Each of the countries have their own top level domains. So top level domains comprise of several generic top level domains and country level top level domains. And we have a second level domain, which is the actual name of which mostly is the name of the hosting machine, right? Host machine which is hosting the internet resource, and sometimes it can be a second level domain which is another domain and then down. Now, for example, here India is the name of the third level domain, and this is the name of the host machine. India.gov.in is the name of the machine, right? And then finally a dot. So India.gov.in dot. Similarly, coidnssecurity.in dot. So that hierarchy has to be followed. And this www is nothing but it's called as a canonical name or an alias name. One can access it using www.india.gov.in or simply india.gov.in. Both names are allowed. So this is the DNS hierarchy. So this root here, which is represented by dot, is the root here. And this TLD here, I have just listed 4 of them, but there are several TLDs. Maybe I'll just show you the internet resource for that. So there are several TLDs, and this is the .in TLD, which is shown here in this diagram. Similarly, we have second level domains, security.in, and this is the security.in. Second level domain, right? Okay, so this is the second. Okay, so this is the DNS hierarchy. So if a recursive resolver is not able to resolve a domain name and provide the IP address to the requesting client, meaning the end device, then the recursive resolver traverses this hierarchy to resolve this hierarchy of name servers to resolve the domain name and return the IP address to the edge device. And that hierarchy is nothing but represented in a logical fashion here in this diagram, right? Okay, fine. So I'll just stop sharing, and I'll before we go to the next part, I'll just take you through a few internet resources. Right. Okay. So this is our website, dnsecurity.in. Hope the sharing is okay. No. Okay. Hope the sharing is visible here. I've just opened the browser, and this is our website, dnsecurity.in. Right. So this is the Wikipedia page for list of internet top level domain names. So you can see here that this is the page of complete internet top level domain names. You have infrastructure top level domain names, you have generic top level domain names, you have country code top level domain names, test top level domain names, just for sake of having it, sponsored top level domain names, right? There are so many categories: infrastructure, generic, sponsored, country code, test, right? So as I said, there is country code top level domain names. So this is the country code top level domain names, and it is, you can see here that there are several countries and their top level domain names, right? And if we come to here, yes, India. So India's top level domain name is .in, right? So in that way, Iraq's is .iq, Iran's is .ir. So this is the list of country code top level domain, CCTLD, right? So this is the CCTLD page. You may visit this for more information on that. And this is the ICANN page, and this is the international regulatory body for the complete internet ecosystem. And as shown in the slides, they are the they are the organization responsible for the complete internet and regulating the registrars, registries, and also the INA. This is the INA, and they are the IP address providers, and they come under the ICANN body for providing internet addresses across the globe to each of the nations and organizations, and ensure proper usage of that. So list of root servers, as I said, these are the list of root servers and their IP addresses and their operator. These are the operators who are taking care of those root servers, right? So these are the A root server, and it goes till M root server. So these are the list of root servers, okay? And you can INA page hosts this list of root servers. right? And this is the page rootservers.org, and you can visit this page, and it shows all the root servers instances present across the globe. There are so many root server instances. There are only 13 of them, but each of those 13 have instances, mirror instances of them across the globe at several locations to ensure good availability and accessibility of internet resources, right? So this diagram can be you can zoom in and have further details seen for that diagram, right? So this is rootservers.org, right? And I think this, okay, fine. Someone, okay, fine. There is a query in the chat box. I'll reply to that. Okay, so there are several types of DNS records. Now, we were talking about the okay, right. So we were talking about the recursive resolvers, and there are several types of recursive resolvers. I mean, authoritative servers. Okay, right. So we came across two types of servers. One was the recursive resolvers, and the other were the name servers, right? And the name servers are the ones which provide the IP address, right? Which have the entries. The dot names root name server will tell the name servers of TLDs. The TLD name servers will tell the name server locations of SLDs, right? Second level domains, right? So all those name servers, they are called as the authoritative name servers because they have the actual entry of the mapping of the domain name to the actual mapping of the domain name to the IP address, right? So in addition to that, the authoritative name servers can be having several other records, and these are a few of the important domain name records which can be present in those DNS servers. Okay, a record meaning it represents an IP address, IPv4 address. A WAA for a record, it means that it represents an IPv6 address. C name is nothing but a canonical name. As we said, codnssecurity.in can also be accessed using www.codnssecurity.in. So the canonical name is www here, right? PTR is nothing but a reverse lookup. A forward lookup implies that you are trying to query for the IP address of a domain name. You are providing a domain name and asking for IP address, and that is a forward lookup. Whereas a reverse lookup is nothing but you are providing an IP address and asking for the domain name which is hosted at that IP address, right? Domain name of that domain name mapped to that IP address. So that is what is a PTR. So a reverse lookup is through a PTR. NS meaning name server records provides the list of name servers. A domain name can have more than one name server. There is more than one name server, and MX is nothing but mail exchange. If there is a mail exchange server hosted in a domain name, and that can be part of that can be shown here. SOA is nothing but start of authority record. Every zone file has a start of authority record. TXT is nothing but textual information of the domain name, which can be added as part of the domain name zone file to add more information about the domain names, right? So that is one thing. The other thing is here. Okay, a DNS setup is done using this Rfc105. Okay, you can visit this page. It is Rfc1035. So this is the specification based on which the DNS domain names are domain name servers are set up, right? So this is the specification for that. So all these DNS servers across the globe follow this specification, which is RFC 1035. Okay, so one may go through that for further understanding, right? Okay, okay, right, I'll just stop sharing here and come back. Okay, right, hope the sharing is visible again. Okay, right, so we have seen till the DNS hierarchy, right? So bind, coming to this, how do we set up DNS server is using bind, right? So bind is one of the softwares. It's a free and open source software. Internet Systems Consortium, ISC, is the body which works on bind, and it is the community which delivers the bind software at regular intervals for hosting DNS servers, right? Domain name servers. So bind is one of the most popular softwares for setting up domain name server. It is a free and open source software. Bind, actually, it has an expansion, which is Berkeley Internet Name Domain. It initially started as a college project, and it was later taken over by the community, ISC, Internet Systems Consortium, and it evolved as a product, right? So it can be used as both a caching server as well as an authoritative server. Okay, bind can both be a caching server and a authoritative server. Right? So these are two components of a bind. One is the name server, the other is the lightweight resolver. Name server maintains a DNS zone file and responds to DNS requests. Right? It has a zone file and it responds to DNS requests. We'll have a look at those files soon. And the name server acts as a caching only name server, right, or an authoritative name server. So it can act as a recursive resolver, or it can also act as an authoritative name server. Authoritative name server meaning it has the authority of responding to by providing a IP address of another machine, right? So it has the actual entry. It is not an entry which it has copied from some other server. So that is authoritative name server. It can act as a lightweight resolver. Okay, lightweight resolver library that can run on the DNS clients like host operating systems. Right, as I said in the a few minutes ago, right, the edge devices also have the capability of catching a mapping between a domain name and IP address within itself, right? And that is what is a lightweight resolver, right? So the bind has following tools also. These are a few of the tools which are present in the bind and which are really useful. Dig is one of the tools. We'll have a look at what exactly is dig in the next slide. But it can resolve DNS. It allows DNS. Dig can be used to resolve DNS queries. Okay, it is a command line tool, and it can be used to resolve DNS queries, and it can check the status of several other entities. For example, just now there was a chat question like, how can we check whether a domain name is DNSSEC enabled or not? Right, dig can do that. Okay, dig has the capability of checking whether a domain name is DNSSEC enabled or not. The host command converts host names to IP addresses. Right, it can convert host names to IP addresses. NS lookup queries DNS servers for information about hosts and domain names. We can look up for a domain name using NS lookup. Named checkconf is one of the tools which can point out syntactical errors in named.conf. Named.conf is a configuration file present in the bind software, and named checkconf can help us because it's a text file. There is no IDE, proper IDE which can be used for checking the syntax or reporting the syntax while writing this named.conf. It's a plain text file. So while writing into a text file, there can be some typo errors which may result in syntactical errors, and named-checkconf can help us check for those syntactical errors. RNDC, which is remote name daemon control, which is nothing but we have a DNS server hosted at some location, and the DNS administrator should be able to remotely connect to that DNS server and monitor and make configuration changes to that. So that there has to be a key exchange between the a terminal from which the DNS administrator is connecting to the DNS server, right? So there has to be a secure key exchange, and encryption routine has to be followed for security purposes, and RNDC ensures that that in order to keep the DNS servers secure, right? So these are the primary tools which are part of the bind software. Right? Dig is nothing but domain information graph. Dig is an administrative tool for querying DNS servers. Okay, it can be used for DNS lookups. It can be used for troubleshooting and verifying the working of a DNS server, right? So dig is a very powerful tool which can be used for throwing several types of query and asking for several types of records from the DNS server. Like DNSSEC is also one of the records which, if configured, will be present and that can be verified using a dig. Right. How do we set up a recursive resolver using bind? Okay, how do you set up a DNS server using bind? So I'll just take you to. No, dig is actually for DNS servers. It does not check whether the host machine is SSL enabled or not. SSL enablement happens at the host machine. This is the machine which provides the internet resource. So I'll just stop sharing and.
Hello.
Yes.
Okay.
Yeah, I'm gonna try. I'm just taking out the VM for demonstration.
Okay, sure.
Right. Hope the sharing is visible. Right. So
Yes.
yeah, thank you. So this is our website, dnsecurity.in, and in this we have the resources page. You can go to the resources page. In the resources page, we have two versions of bind available here, right? So this is the 9.16.6, which was the previous version, and the current stable version, which was released just last month, is 9.18.2, and that is available here for download. You can click here and download the 9.18.2 bind version, stable version, and one can follow the instructions given here in this manual. We have uploaded a manual, and this manual can be straight away used for setting up a recursive resolver, right? Your machine, you're supposed to have operating system CentOS 8.x version, right? The machine should have an internet connection, and all the commands are to be executed as root user, right? You should be executing the commands as a root user, and you should have a valid IP address, right? The machine should have a valid IP address. So this manual is prepared for setting up a bind resolver using bind resolver using 9.18.2, right? 9.18 bind resolver, and the operating system is supposed to be CentOS 8, any of the 8 versions, right? And you should have a root user privilege, right? You should be the root user there. Okay, right. And this is the 10 steps in this. You can download the bind software from our website, right? You can download here, go to that website, resources page, and download it. Once you have downloaded, I have already downloaded here, and I have the bind software present here, right? Bind 9.18.2 is already present here, right? Now let's start setting up the tool bind resolver, and there are two approaches to it. One is that bind comes with the Linux flavored operating systems. It comes with CentOS, Ubuntu, several other Linux flavored operating systems have bind with them, right? Meaning they have bind packaged as part of their library packages. So one can always download directly and install bind onto a Linux flavor machine using their respective install commands like yum for CentOS, apt-get for Ubuntu, or so on, right? Bind and bind utils are the name of the packages present across the Linux packagings, library packagings, and they can be set up easily using one command line, right? One just terminal command line. But the problem would be that it depends how updated the library packages of those operating systems are. So if we directly command using yum install bind utils, if I give it here, if I give a yum install bind utils, this would provide me a version of bind installed on my machine straight away. But this will download from the CentOS package, and yeah, it's available on other operating systems also, right? It's available. So you can straight away using this one command line, one can set up bind. But the a library package of that respective operating system may not be up to date. So the recent stable version of bind is 9.18.2. So it may be having a 9.16 version or 9.14 version. So you may have a predated version of bind set up on your machine if you are trying to do that. So in order to go for the most recent version of the bind, we have taken this approach where we download the source code, and this is that source code. And this is that source code. It's a tar file. This is that source code. We have downloaded that, and it is also hosted in the CODNS security.in resources page. So we download this source code, and we add all the required libraries required for the working of bind and for security configurations of bind. We add all those libraries and then set up and then try to set up the bind and then try to build the bind software and set up the DNS server, right? So one can directly take the statements from here and start installing. For example, yum install epl release is the package, and this is nothing but these are extra packages for enterprise Linux. Okay, EPL they call it, extra packages for enterprise Linux. So I'm just installing it. So it's already installed and present in this. So we can go to the now GCC compiler, because there are a few libraries which are C++ based libraries. So in order to install those C++ based libraries, compile and build those C++ libraries, we need this GCC compiler. So this is also complete, and okay, and then we make yum install make install the make tool, okay, which is present, and we do yum install lib which is a library for all the UDP TCP socket interactions. Need this, and we are setting that. So this is a library which is getting downloaded. It will take a couple of seconds. Yeah, it's done. And then we have the Dell level pack of that. So we have the DNF. You can notice here that I'm a root user here, right? So root user is the privilege using which I'm doing all this. Repo equal to power tools install lib. So it'll take a couple of minutes. Okay, and the installation is complete. And then I have the OpenSSL to be installed, because there are several key exchanges which have to be regulated between the different hierarchies of DNS and the primary and secondary servers. Okay. Okay, so the OpenSSL is complete, and I have the JSON library to be installed for data exchange format. Okay, so we could successfully install the JSON library also, and we have seen that there are a few cases where in few of the CentOS flavors we were not able to install these JSON libraries, and if it doesn't work, then we have the alternative workflow listed here in this box, right? So, and then we have a libxml library which has to be installed. So Okay. Right, so the libxm is installed, and then we have the app. Sorry. It's a typo error. Okay, and then we have the libng HTTP library for we need to install the Dell package of that. Okay.
We missed a single dash, I think.
Yeah, it's now done. I corrected that. Thank you. Yeah, so the libraries have been, dependencies have been installed, right? And now let's now try to extract the bind. We have this bind here, right? We'll extract the bind software now. And okay, it's now extracted. Go inside the bind directory, and then now I need to configure the libraries in the bind software. Trying to include the dependencies. Okay, so it has been configured. It has been bundled as a single package now. Now we build it. Now it's compiling and building the software. Yes, it's complete. So now we can install the software, which is right. So the installation is complete, and now we have actually the server is now set up and is running, and we can verify that by saying named 1v. You can see that there is a server running, and this is the ID of that. is the ID of that. Bind 9.18.2 stable release is the version, and this is the ID allocated to that. So this is the server which is running, and for a remote control to be given to the DNS administrator, we need to have this RNDC configured. As I earlier said, it's a remote control daemon for remote control of the DNS server by the DNS administrator, right? So it has written the key now, and we'd like to change the mode of the key because it should be writable. So which user local dc slash dc dot key, right? So changing the mode of that key. It should be readable because this key is the one which gets exchanged between the machine, and from that the DNS administrator is trying to control the DNS server and try to make configurations to that. So that is this key. And coming to the primary part, make it capable of resolving domain names. It's nothing but we go to the user local etc folder. We need to create a file which by convention is named as named.conf. Named.conf is the name of the file, which is the configuration file, has to be named as named.conf. And I'm using the Nano editor, and we put options. This is the starting of the file. And as you know, DNS protocol works on UDP primarily, and it uses TCP for certain cases whenever there is a requirement like key exchange or data exchange, or when the traffic is more than the normal size, then a TCP connection is established, right? But normally it listens on a UDP connection, right? So and the port is 53, UDP connection port is 53, and 127.0.0.1 is the loopback IP address. And let me check the IP address of this. Okay, right. So it's 192.168. So this is the server's IP address, which is my machine's IP address on which I'm working. I'm creating the zone file, right? So I have this, and I want to allow query to it. It should be accepting queries from anywhere across the internet. It should be responding to my queries, right? And it should, if it does not have the entry within itself, then it should say recursion. Yes, it should allow for a recursion. It should allow for DNSSEC validation. DNSSEC validation is to ensure that the servers which are interacting among themselves have a trust value within themselves to exchange records between them, and that is what is DNS. And this really avoids DNS cache poisoning to a larger extent. So DNSSEC is the means for that. We have the bind keys file, which are for the RNDC. So user etc bind keys local set and semicolon, right? Then I include the RNDC key also, /user /dc/RNDC key. Okay, so I have included that. and I came out of the file now. It's written now. I now need to check. You can notice that it is just a text file, right? And you have certain syntax to be followed. You have some curly braces, and you have some semicolons to be placed, and the syntax should be proper, right? So in order to validate the syntax of the file, we have this tool named -checkconf. Okay, so if there were any syntactical errors in the text file, then the named-checkconf would have reported that. Because it hasn't reported anything, it implies that the file is absolutely fine and it is working, right? So now I need to start the server. I'm the named user. The server has to be started with as a named user. Bind gets started as a named user, right? So named user C and the user /local, and it has to start with which configuration, and that is this configuration named.conf. So it has to load the named.conf and start execution, right? So I'm starting the server. The server is started now. I need to verify this server whether it's started or not. So I'm just checking the process status. If there is a process by name named. So there is a process by name named, right? So this is the one which is running, right? So this is the named server which is running, right? So the server is running, and I can just give 127.0.0.1. I'm doing a dig domain information grabber for using the loopback address, which is the current machine on which I hosted the bind DNS server, and I'm providing a domain name, and using this server, I'm trying to look for cdac.in, right? Okay, so here is the answer section. I gave a query and I asked for cdac.in. By default, the query is for a record. By default, I haven't specified any option here. I could have also specified the option here, but I have just given it plainly, just providing the domain name. So by default, the query has gone for a record, meaning it has asked for a IPv4 address, right? So the answer section is here, and it has returned the IP address of the cdac.in. So this is the IP address of cdac.in. Now I can also ask for something like a record of COE-DNS security in. So I'm asking for IPv6 address of COE-DNS security.in. So there is no IPv6 address for that. Okay, so it has just returned the question, and the answer says 0. Right now, let's check whether it provides for a record. Okay, right. So it has an IPv4 address, so it has returned a IPv4 address in the answer section. Right. So it says answer 1 here, and this is the answer section. Right. So it is providing the result. So this is about the setting up of a recursive resolver. So we have just set up a recursive resolver. Recursive resolver is the first landing point of a query from a client, from an end device looking forward to resolve a domain name. And this is the manual for setting up of the recursive resolver. One may go through that. It is available at this URL on the resources page of COE-security.in, right? So these are the Internet Security Consortium, Internet Systems Consortium, ISC's website, where you can look for the requirements, configurations. We have actually extracted the information from there and done this assignment. So these two URLs can be of extreme use for further understanding of what exactly is happening in this, right? So that is about setting up of a recursive resolver, right? So I'll just stop sharing and go back to the slide. Okay, right. So we had a look at how to set up a DNS server recursive resolver using bind. So resources are available codnsecurity.in. People may always try that and have a better understanding of that, right? So coming to an authoritative DNS server. Now, if you asking me what is an authoritative DNS server, I'll just take back you to this hierarchy. So these three servers in the DNS hierarchy are the ones which are called as the authoritative name servers. This is the root authoritative name server. This is the TLD authoritative name server, and this is the SLD, second level domain authoritative server, right? So all of these resolutions here in this DNS hierarchy are supported by name servers, right? Authoritative name servers, right? So these are the ones which provide information of the location of other name servers or other domain names, right? So for example, dot provides the root authoritative root authoritative server provides information about the name servers for TLDs. The TLD authoritative name servers provide information about second level domain name servers, right? And second level domain name servers either provide the IP address or they redirect to the third level domain names, right? So that is what is an authoritative server. So an authoritative DNS server is the name server that provides an authoritative answer to queries from recursive DNS name server, right? So from a recursive resolver, any queries that land at the authoritative DNS server, right? And types of the authoritative DNS servers are root servers, primary and secondary, right? Several of them. Okay, so DNS zone file is a text file containing all DNS zone information. So to make an entry in authoritative name server, we have something called as a zone file. We need to create a zone file for a given domain in a authoritative name server, and the format of that has to be as per the RFC1035, which I have just.
You are not audible, please.
Yeah. Okay. Okay now. Yes. Okay.
It's audible, sir. It's audible.
Okay, fine. Thank you. Yeah. So we have DNS zone files, which are text files, which are placed in the authoritative name servers, and these contain the entries of a given domain name, right? And these zone files have to be created as per the specifications given in RFC 1035. Okay. Right. So there are several parts of the zone file. So for example, there is $origin, which indicates the start of the zone file. Okay, and at the rate indicates the origin of the, meaning this start is what is this. Wherever I use at the rate, it means that I'm considering this ditto origin under that. SOA means a start of authority, right? So here is a sample zone file entry. Okay, at the rate, which is nothing but whichever is the origin, this origin will come here at the rate, right? And it has in meaning it's for internet usage. and SOA meaning because domain name system can also be local to a internet facility, right? So if you are using for an internet facility, then it is in capital N, and SOA, which indicates the start of authority, right? And we have the name server listing can be done here. Host master email ID, meaning DNS administrator's email ID is to be listed here. We have the serial number. There is no specification as to what number has to go here, but it is just a serial number to identify the synchronization between a primary DNS server and its respective secondary DNS server for regular update of this zone file. If there is a we can call this as a version number of this file. Serial number can also be understood as a version number of this file. So let's say that 122 is the serial number for a zone file in the primary machine, and 121 is the serial number in the secondary primary machine, meaning at some point of time the serial number of primary was 121, which was actually taken by the secondary, downloaded by the secondary server and kept there. And when the request from secondary server comes with the serial number and it checks for the serial number in the primary, if the primary serial number is different from what is actually present in the secondary, then the data is pushed to the secondary and the secondary server gets updated with the entries, right? So that is what is a serial number. And this is the time to refresh. Time to refresh is nothing but waiting for secondary servers to check for a change in a serial number. Okay, the how frequently a secondary server has to approach the primary in order to check for a change in the serial number, meaning a version upgrade. That is what is the refresh rate. And suppose the secondary server failed while trying to contact the primary server for some reasons, after how much time the secondary server should again try for a connect with the primary server, and that is what is this time to retry. Okay, and how many number of retries, for how long a retry can happen, that is what is time to expire, right? That indicates the time to expire. And this is the minimum TTL. Minimum TTL meaning catching time for negative response. The time for which a response has to be negative response has to be cached in the server. Okay, right? So NX domain or server failure has to be captured and stored in the cache is what is time to live. Okay, right? So these are the values. Okay, so these are the same values which we have seen here. It is nothing but serial number, refresh date, retry, expire, and TTL, and those are again explained here. So we'll just go to the file setup and again check. We'll move to the VM. So I'll just stop sharing now. I'm just getting the VM up. Okay. Yes. Hope the sharing is visible now. Okay. Okay. This is now we had seen a demo of how to set up a recursive resolver, and now we'll just go through setup of authoritative name server, right? So you can see here that I have the named.conf here and I have the test.in here, right? Just remember these two names. I'll just cat named. So this is the normal configuration for recursive resolver, which we did earlier. We already know that, we have seen that, right? This part. And suppose I want to have in this case we have the recursive resolver acting as a authoritative name server also additionally, with additional responsibility for test.in. Sorry, test.in domain name, right? So it's just a sample domain name, test.in, and the recursive resolver is also acting as a domain name, I mean authoritative name server for test.in. So in order to enable this recursive resolver or this bind server to act as authoritative name server for test.in, I need to add this entry into that, right? So I need to include this zone into that. So I say zone for zone test.in is the domain name, and it's meant for internet .in, and it's a master type. It's the master one. It's not the slave one. I'm configuring for the primary, right? I'm configuring the primary server as of now, not considering the secondary server, right? So type master, and this is the file in which it has the zone entry. So you can see here it is user local etc test.in. Okay, if you see the path here, it is the same path, user local etc, right? So this named.conf and test.in are located in the same location, right? So so if this DNS server is asked for test.in, the request will come to this zone. This zone will see that it has test.in, and it will go to this file in order to resolve for test.in. So this test.in file is supposed to have the entry for resolving the request, right? So I'll just start, right? So just clear. Okay, all right. So you can see here at the rate in SOA start of authority record. Okay, right. So I have the test.in domain name for which I'm creating the zone file. This is the root at the rate test.in. I have a dot here, but this dot is actually a representation of at the rate. So ideally, this is supposed to be the email ID of the DNS server administrator. It is actually root at the rate test.in. Okay, the DNS server administrator for test.in's name server, right? So the at the rate has to be replaced with a dot in this case, right? And you can see here always there is a dot after the in. Okay, there is always a dot after the in every place, right? And this dot is what is the root. It is a representation of the root, right? So root at test.in is the administrator email ID, and this is the serial number. And this is the refresh rate. 1 day is the refresh rate. So the secondary server is supposed to contact the primary server for updates for difference in serial number. Difference in serial number indicates that there is a zone file update to be done. So the secondary server has to contact this primary server every day. So 1 day it has to contact every day. If it fails at one of its attempts, then it has to retry in 1 hour, 1H. 1 hour, 1H meaning 1 hour. It has to try every 1 hour. Okay, and it has to keep trying for every 1 hour for 1 week. Okay, till that is 1 week is the time in the it expires. It concludes after 1 week that the primary server is dead and is not available for response. So that is the time 1 week, right? And this is the time to live 3H. Time to live is the time for which a value can be held, can be saved and stored in the cache, and that is what is 3 hours, right? So that is 3 hours, and this is the name server, and this is the IP address of this machine, and this name server will is hosted at this IP address, and this name server responds to test.in. Okay, tries to resolve test.in, and it provides the A record, which is IPv4 record, and that is this. And it has a C name, which is www, right? It has a www C name, right? So we can always check this by saying that I say dig. I'm asking the name server 10.0.2.5, and I'm asking it to respond for 10.in. Okay, I'm asking it to provide me the IPv4 address of 10.in, right? So I'm using dig, and I'm asking the name server 10.0.2.5 for the A record, IPv4 record of test.in, right? So I say here. So it returns the answer section, and it says 192.168.2.10. That is this address. Is it this address? It returns me this address, right? So I'm able to resolve test.in using this. So now my recursive resolver is able to act as a authoritative server, name server also, right? So stop sharing here. Do I need to install C++ on Windows too, so or it is available in bind package only? No, a separate installation has to be done. Bind doesn't come with that package. There was a question. I'm answering that question in the chat window. The question is that do I need to install C++ on Windows, or does it come with a bind software? Bind doesn't come with the C++ compiler. We need to install it separately. Right. Okay. So I'll stop sharing. Come back to the presentation. Yes, hope the presentation is visible. So this is the zone file for Authoritative Dns Server, and we just saw how to what all entries can go into that. These are the references, and we have hosted the software bind 9.18.2. It's a software package itself. It's not an installer. So you need to download this software and follow the instructions as given in this manual here down, and follow the manual. We have gone through this manual several iterations, and it is really very good, and there are no mistakes possible while following this manual to set up a recursive resolver, right? And you can also go through this RFC8035, which is a specification of DNS and its configuration files. It has to be the way it has to be, that it can so that the DNS ecosystem works with the proper standards. That is ensured using this RFC8035. So I think that is the part of this thing, and so we are hosting a public DNS resolver at this location, IP address, IPv4 and IPv6 address. We have made it DNSSEC enabled, and we have made it RFC8806 compliant. Now, what is RFC8806? You may definitely Google for RFC8806. It's an interesting part. And if you ask me what is RFC806, I'll briefly just tell you here. Okay, fine. So suppose let's assume that a recursive resolver does not have an entry, then the recursive resolver has to traverse through this complete DNS hierarchy, right? So instead of approaching the root server, it is possible to host an instance of root server in the recursive resolver itself, and that is what is RFC8806. So by doing that, this step 4 can be totally removed, and recursive resolver can pick the entry from within itself as a local server. It has an instance of root server within itself, and that is what is RFC8806. So this step 4 will be removed by that. So one hop is getting removed from the total traversal, and that is what is RFC8806. I have a request to make here. We are also working on email security. There is a next brief section on email security, and following the email security session, we'll have the quiz for the day. To support our email security, and it's a AI based model for email security. So to strengthen our email security model, we request we request everyone to please send the spam emails that you have received from several agencies into our email box at spam@coednsecurity.in. So we collect the emails at this email box, and we use them for model building of email security. So that is from my side. And the next instructor would be Mr. Jitendra Kumar. I'll just hand it over to Jitendra Kumar. Jitendra?
Yeah, I'm here. Thanks, OP.
Okay, thank you. So I'll stop sharing and you take over. Thank you.
Okay. Is my PPT visible? Hello?
Yes, visible.
Okay. Yeah, my name is Jitendra Kumar. I am Joint Director at CDEC Bengaluru. Basically, this topic is for email safeness scorer, which we have developed. It's a tool, and this tool provides a solution for phishing email. And then I want to just briefly cover, because we have a very less time. Actually, I could have covered email security part also. Since email phishing is also a very important topic, then I would basically try to cover this topic, and I will try to discuss about the email safeness scorer. Then let me see what's the email safeness scorer. And we have given this tool name email safe. This is just a name for the email safeness scorer in a brief. Then email safeness scorer, a privacy preserving machine learning based client side. Basically, it's a Mozilla Thunderbird plugin to provide safeness score of an email for alerting the user about the possible phishing and scam etc. As you may be aware that phishing is a very genuine problem, and this happens on the daily basis, and most of time email is used as a medium for the phishing. That's why this solution, email safeness scorer, would provide you a certain kind of a score for an email, and based on that score you can say whether that email is phishing or email or not. Then email safeness scorer is an application which would provide the safeness score of the email based on its content. Basically, this email safeness scorer or email safe analyze the content, and based on the content it says that whether that email is a probable phishing email or a genuine email. Then low safeness scorer will tell you that the given email is a dubious, scam, phishing, or malicious or spam emails. If a score is high, then it tells you that that email is a benign email or it's a non-malicious email. This solution is available at this particular URL. COE DNS security emailsec.email. You can download it and use it. This is already available at this particular URL. Then just let us briefly discuss about the email phishing problem. And email phishing problem is you may be most of you already are aware of this particular problem, because on the daily basis we are getting so many spam emails, and many spam emails tries to fish the victims. Basically, those these phishing emails can be categorized in some few category. Like certain emails will be for advertising, certain email will contain the malware, and the main intention of those emails to infect the victims with the malware. As certain emails will try to get your sensitive informations using the social engineering techniques. Then basically phishing emails are unsolicited email sent for either advertising the product and services, or try to phishing the gullible users for sharing important sensitive informations. Then these are the main intention. First intention is that they will try to advertise about their product and services, and second is try to phish you for sharing your private information. And those private information basically maybe your credit card information, bank password, bank account number, your email password, something like this. Then phishing email and spam emails are generally undesired, and sometimes most of the time it is sent in the unsolicited and in the bulk manner. Then for solving this email phishing, there are various algorithms has been designed, because this email phishing emerges on the daily basis. Always new kind pattern of the emails emerges. That's why the normal techniques are having limited scope for this. That's why actually certain machine learning techniques have been also developed, but there also problems are there. In those algorithms also we have seen certain problems. Basically, some are successful and effective, and others are highly biased. I mean, sometimes so bias is there, it requires the regular training. Then for solving this particular email phishing problem, we have developed our own multi-layer neural network, and I have developed adaptive neural network algorithm with the adaptive gradient descent learning learning algorithm. Then what we found that our solution works better than some of the existing solution, because existing solution are biased, and most of time it doesn't give the correct result. And let us try to briefly discuss about the phishing. Basically, email phishings are of three types. First type is called deceptive phishing, and here main trick is the deception. In this particular deceptive phishing, the main idea for phishing the victim is the deception. In this, what happens, a cyber criminal tries to impersonate a non-entity, person, domain, or certain organization. It will try to impersonate and say that I am that particular person. And what it does, after impersonating, it will create a mail, try to convince the victim for revealing their sensitive private information. And those private information can be login, password, bank detail, etc. This deceptive phishing basically lacks the sophistication. I mean, say lack the sophistication means it does not have personalized information about the victim and customization of the individual level. Most of time you can find out this email is a spam or deceptive phishing, because it lacks the personalization about the victim. It will not have convincing information about the victim, such the victim can be convinced that this is the genuine email. For an example, an phishing email, some phishing URL, a email may contain a phishing URL, and it will be disseminated in the large proportion to the large number of users. And cyber criminal may think that someone will open, and once opens, that infected URL may have certain kind of malware attachment, and that may get installed into the system. This is one trick. And another trick is that some email content will be something like it will be like something that will create the urgency means something like that your account has been hacked, change your password immediately, your bill is overdue, pay immediately or pay a fine. Means this kind of wording will be there in the email, and it will try to create urgency and panic to the victims. And in the panic mode or urgency, what will happen? The victim might click on the link, and once he clicks, the damage is done. Then in this deceptive phishing is just a basic trick, is a deception, and for doing deceptions, these are certain tricks like they use, and they try to fish the gullible victims. Another popular is called spear phishing. In the case of spear phishing, hello, I am audible to all of you.
Yes, sir, audible.
Yeah. Another is the spear phishing. This is also a deceptive phishing only, but here in this type of phishing, it will have abundance of the personalization information about the prospective victims, because the email may contain your personalized information, something like that. It might contain your name, company name, designation, your friends, colleagues, and other social informations. Then this kind of email will be very convincing to the victim. It may look like very genuine. And the proliferation of company websites, personal websites, social media, etc., enables cyber criminal to get certain details, such details very easily. Basically, this spear phishing is done through the social engineering. Social engineering means nothing but gathering the personalized information using the social media. Then nowadays, what happens? Many information, personal informations are available on the social media. Then what cyber criminal will do? Cyber criminal will try to get all those information from the about a victim from the social media, and try to create a very convincing email and send to the victim. And once a victim either downloaded some certain attachment or clicked on certain malicious URL, then damage is done. Then the last one is a whale phishing. Whale is nothing but a top leader, top business leader of the something like CEO or top level management of the organization. In this kind of phishing, the cyber criminal tries to fish or tries to catch the whale of the organization. Means try to fish the whale of the organization, means top executive. And main aim of this type of phishing to gather confidential information from the CEO and tries to impersonate as the CEO, because here the person or victim is a top level management. That's why in this case damage can be maximum. Damage up to the level is that it will have a financial prospects. It may damage the company financial prospects, market value, and the reputations. Then basically these are the many phishing. These are the three popular phishing techniques, and here social engineering are in play. Most of the inform tries to some of the for product advertisement, and many are trying to phishing the victims. Then we have developed a solution. We have given the name as a email safe. Then email safe is a solution. It contains a client-side component that contain a neural network model. We have a trained neural network model, and that trained neural network model we will have at the client. Then the email in the form of feature vector. Generally at the client side, what we do, we will take the content of the email and convert into the feature vector. That feature vector is an input for the neural network, and this feature vector is converted at the client itself, and after that it will be sent to the email safe server, and that email safe server will decide about the safeness score of the email. Hello? Hello? Yeah. I think someone has a mic. I think it's echoing. Yeah. Now it's okay. Then NN model in eSafe is updated regularly from the global email safeness modeler. Means we have a global safeness modeler also, and we have a latest updated model over there, and local model is updated regularly from there. Email safe over the time develop a customized safeness scoring system for the given user with the local and global knowledge. The model is safe within the control of the user, and even multiple persona can be created. Means every person will have its own neural network model. Means you can have a personalized neural network model for each and every person. Privacy is preserved because no input is given sent to the email SAP, because the feature vector is generated at the client itself. This is a architectural diagram you can see here. This is a email SAP, a small component which reside at the client itself, and a client means a client something like Thunderbird. It will client like a Thunderbird feature vector will be created and will be sent to the email Safeness server, and email Safeness will return the score, and this email safe local server will be always updated from the global email Safeness modeler. Then email Safeness scorer for Thunderbird, it comes as a Thunderbird. Yeah.
Jitendra, just sorry to interrupt.
Yeah.
Another 5 minutes, shall we try to?
Yeah. Just 5 minutes I will complete.
Okay.
Huh?
Okay.
Yeah. Email Safeness scorer comes as a Thunderbird plugin. And already I have discussed about what's the global Safeness modeler. It's nothing but a model which we will keep as the global level. Then we will come to here how to this is the impact means if we are able to classify a spam and a scam, then it's very useful for general society and for the user, because he will be able to know whether this email is a phishing, and accordingly it will alert them against the exploitation from the malicious email and potential financial loss etc. and reputation. Then this work is based on one paper. This was published here, and this paper has a in this paper our model actually we got 99.12% accuracy. The strength is that currently we have trained this model on 4,000 data set, and what Gopi has already told that we are actually accumulating and gathering many other emails such that we can have a more data set for training, and our accuracy can be improved. Currently our feature vector size is 1900. Then this is certain snapshot of the solution. You can see here this is a spam email, and here it's showing the score as 9%. This is also a spam email, it's showing the score as 4%, and similarly this is a genuine email, and you can see here it's showing the 61%. And these are nothing but then sorry. And these are my research work. Based on that, that email Safeness was developed. I'm not going through that. And this is the last comparison. Our actual adaptive neural network has a better accuracy, and moreover, it is having less overfitting problem. Even all the other algorithm has even 98% accuracy, but the given 4,000 data set, it has very less accuracy. Then this is the end of the slide. And if I would like to give demo, then I will try to where it has gone. I would like to share my screen. Actually, I am not able to share. How to share? Hello, Gopi. Hello.
Yes, Jiten. Yes.
Gopi, actually, I am not able to share my that Thunderbird screenshot, and
Okay.
I don't know. I'm not able to switch over the another screen. I don't know how to do. That's why.
Okay.
That's it from my side.
Okay, fine. Thank you. Thank you, Jitendra.
Yeah.
Thank you for the session on email security, Jitendra.
Yeah.
And here I'll just conclude in 2 minutes. So this is our portal CODNSecurity.in, and we publish several material in this portal, and people can always visit this website for further information. As I already said, the resources page has several manuals, and you can go through these manuals and try your hands-on with those manuals. We have the public resolver details here. One can always try to configure with this public resolver and work on it. And there is an interesting page on tool. We try to determine the health status of the name servers of the DNS ecosystem, and this is one of the tools for that. CODNS health tool. So if we give a domain name here and click on submit, it will provide you the details of the health status of the server along several verticals of all the name servers for a given domain name, right? And this is a spam box. As already indicated, we have spam at CODNSecurity.in, where we gather the details, and training details are always hosted at this website, and previous training details and the current ongoing training details will also be provided at this link. So that's all from our side, and we have a small quiz to be answered, and Jitendra, you are sharing your window.
Yeah. Now I'm able to share. You can see here, this is a tool. It will appear at this particular place at the top end corner, and if you click, it will give you the score about the email. You can see this is a spam email, and for this spam email, you can see the score is very less. Similarly, this is also a spam email, and for this score is very less. And this is a genuine email, this one I think, and then a score is go 74%. Then this comes as an installer. I think the DNS COE DNS security website, we have a complete tool as well as installation instructions also. I request all of you to download it and use it. Yeah, that's it, Gopi.
Thank you.
What was the name of tool? Excuse me, sir.
Yes, Jitendra, there is a query.
Yeah.
Sir, what was the name of that tool?
It's a email as Safeness Scholar with the name it is available.
Okay,
So,
so is it a tool or an add-on to browser?
It's a plugin to the browser, but you have to install certain component which works in the Python also. That is also there in that.
Okay, okay, sir. Thank you.
Because machine learning thing you can't do in the browser, something like Thunderbird.
Okay.
It doesn't support. That's why the machine learning related thing, we have a separate component which works in a Python, and instructions are there how to install. It's very easy. Just install Python, and you have to run a pip, and you have to install NumPy, NLTK, and one Flash server, and after that you have to just run it, and then you can install this plugin in the Thunderbird plugin and Thunderbird client, and now you can use it like this. It is there. Instructions are there in that.
Sure, sir. Sure.
And if you are not able to do, please contact to me or contact
Okay,
to
sir.
us. Yeah.
Sure, sir.
Yeah. Thanks.
Thank you, Jitendra.
Yeah.
So I have posted the quiz link in the chat window, and it's comprises of 20 simple questions and for 15 minutes. Please visit the link and submit your responses, and based on the quiz response, the certificates will be issued. Thank you. If there are no more questions, then we can conclude the session.
So basically, I'm requesting joint registrar for final words. So I think we have to give few more minutes. Gopinath,
Sure.
the feedback team.
Okay. Sure. Jitendra, you can remove the sharing.
Yeah.
Thank you.
Hello, Mr. Gopinath. Are you available?
Yes.
Okay, so I request our joint registrar, Shri Ayan Gaikwad, to to give the final remark to this wonderful workshop.
Good evening, all the participants. In the number of workshop that we plan to conduct regularly at Nfsu Delhi campus, I think we have made a very nice beginning. The contents of the course, we will take a feedback and come to know whether we need to tweak something or add a little more in the subsequent workshops. But I'm extremely happy that in a very short time, Harish and the team from CDAC and support from Mehti, we've been able to put our act together and we come out with this workshop. I would like to especially thank Mr. Santosh from Mehti for providing the support. And I would like to thank Dr. Sudarshan, Bindu Madhava, and especially Gopinath for arrangement for holding this workshop. Like I said, NFSU would like to work very closely with CDAC under the guidance and umbrella of METI, which is the model or the main agency of the Government of India, who is looking into all the IT related issues. I'm sure the participant would have gained from today's workshop. It's a lesser known topic, everyone understands, but that does not mean it is not important. I think one of the most neglected areas in our country is internet governance, which is not only this ignorance is not only stopping us from being a very active participant in policymaking worldwide, but it needs to be taken up on a very larger scale or at the international level. And NFSU would like to play the part of being the mouthpiece of the ministry and all the other related agencies under the Government of India. Why NFSU I thought is the ideal organization, because we are primarily academic institutions. 25 to 30% of our effort should definitely be towards the research and development and policy making in case of internet governance. So since we have a large turnover of not only students, we conduct a lot of in-service training for senior officers from judiciary, law enforcement agencies and scientific community. It would be easier for us to gather the inputs from course to course, put them in the right, make some kind of an architecture towards making the draft policy. And of course, with the help of CDAC and METI, we should be able to give a very rough direction to the thought process, which would be in the long run be issued as a doctrine related to not only internet governance, but all related activities, whether it is DNS or forensic on DNS, forensics on internet governance. All these issues we should be able to come out with in a form of a policy which would come down in the form of a SOP for various organizations to follow, so that in one voice we represent the Government of India, our nation, and our thought process on the not only internet governance but all the other IoT related activities. Once again, I am very glad. In fact, I spoke to Dr. Junare. He is traveling and he is assured that next time probably we'll make sure that VC is also adequately prepared to be online and address the audience plus the participating teams from NFSU and CDAC. Once again, I personally would like to thank each member of the CDAC team from METI and of course our home team of NFSU members for putting up this workshop in a very short notice. Let me be very candid about it. The number of participants, to be very frank, I had not expected. Yet we said we will still go ahead with the workshop, attract more participants in the subsequent course. But I think we have made a much better beginning from day one onwards. And I feel the participants of this workshop would be our ambassadors to not do the publicity, not to gain more number, but to spread the awareness regarding internet governance and its applicability in the forensics, for which our university is only the learning center in the country and also global. With this, may I request Mr. Santosh to say a few words and the other participants from the team members from CDAC, if you would like to add something.
Thank you, sir. Sir, I think Santosh sir has left. I think he's not seen the window. Okay.
From the
Thank you very much.
organizing team would like to put in a word?
Sorry, sir.
Gopi, you or anyone else from the CDAC team would like to say something?
Yes, sir. Yes, sir. Yes, sir. Definitely. Yes, sir. First of all, I'd like to thank NFSU and Mighty and Santosh sir for giving us this opportunity to conduct this webinar and deliver and connect with NFSU and its students. We thank for this opportunity, and it has been a great pleasure coordinating the activity with Mr. Harish Chaudhary. I thank Mr. Harish Chaudhary for the opportunity and the facilitation that he had provided. This webinar was just a starting stage. It is just a baby step towards a DNS ecosystem. There are many more things to be learned in the DNS ecosystem, and we are always ready to help you and provide further workshops in further technologies of the DNS ecosystem. You are always welcome to approach us for the same. Overall, I would like to thank CDAC and NFSU and Mighty for this opportunity. Thank you very much, and special thanks to Mr. Harish Chaudhary.
Thanks, Gopi.
Shall we conclude the session? End the meeting?
Yes, we can conclude. In the end, I would once again like to thank all the participants from NFSU and organizing staff from Mighty, CDAC, and NFSU. Thanks a lot.
Thank you, everyone. Bye-bye.
Bye.
Thanks a lot for your support, sir.
Thank you, sir. Bye-bye. Bye.